Yes, sir.
Yes, sir.
రోడ్ అవ్వచ్చు ఏమంటే చేయాలి నాకు కూడా ఒక లవ్ ఉంది దానికి కూడా ఒక బడ్జెట్ ఉంది అవుట్ఫిట్ అయితే సింపుల్గా ఉండదు మరి డైలీ అవుట్ఫిట్ చేయాలిగా మరి ఇంటిని కలుస్తాం రైట్ చేయాలి డ్రెస్
So, how we want to start? You want to give some feedback till now? Now I think it is like we started like a Gaussian optics. So, how was the experience in optics? So, optics was hard, or Gaussian optics is hard. Okay, Gaussian you feel little bit hard. Actually, there is not much mathematics is not involved. Na? You don't have to think more of mathematics in Gaussian optics. Okay, in that initial part only you are seeing some mathematical derivation and other things, but actually it is not that much bad, I would say, or hard. Actually, you can just see what are the good things or what are the important things in that Gaussian optics, and you can just go on for your purpose. Actually, that will be more than
Okay.
okay. So, you want any clarification regarding Gaussian optics or something, or going through assignment itself, whether you want to get it clarified, or what is your intention? It's like, yeah. So your side, you can give comments so that we can go like that. Anyway, I don't have any problem. Or you can start solving that the previous assignments, and you can see what are the things which is involved. And you maybe already noticed that you are that sixth assignment, the 9 and 10 questions are cancelled. Only 0 weightage will be there for that answer. Yeah, that was a mistake in that question.
Yes, sir. Yes.
Yeah.
Thank you for that. Sir.
Yeah,
Yes.
that I informed them such that yeah.
Yes.
Yeah. Or can we move to that assignment part, or you want a specific doubts regarding this one, and then we have to go to the assignment part, or in between the assignment you will get the doubt or something like that.
Maybe in between assignments.
Okay.
So that's fine.
Okay. So let us see how could you people solve the assignments. And you people have basic integration ideas and other things, how these areas are getting calculated and other things, you know. Any idea? Or that thing made you more difficult towards Gaussian optics, like yeah, you are calculating power and intensity kind of things. So okay, anyway, let us move to that assignment, and we can see that how hard or how complicated it is. Okay, I'm going to share my screen. Is my screen visible? Is the screen visible?
Yes, sir.
Okay.
Yes.
Now you can see. First question is like that way. At an axial distance of z0 or Rayleigh range from the beam waist of a Gaussian beam, the phase of the beam axis is retarded by dash radian relative to the phase of a plane wave. Plane wave, that's the question. A pi by 2, pi by 8, pi by 4, pi. Now you see, actually what is the plane wave? What's the Gaussian wave? That you have idea, or you want some clarification? What is actually a plane wave? What is a wave? Hello, am I audible?
Yes, sir.
Yeah.
Like constant phase along
Yeah.
like that, is it?
The wave is a shape. You can say that a shape is actually moving one place to another, or you can say the energy transfer or a transfer of a phase. You can say, or you can say it's transfer of a shape, just without any particular movement of the particle. You can say like that. So this is the wave which is comprised in very earlier thing. So how you define like that way? You people are already seeing like that way. If there's a thread and you made a stretch here and just think that if this side is tied, you can see that after some time this shape will move here, and after some time the shape will move here, like that you can see what is actually moving, whether that the particle on the thread is, whether it is moving from this place to this place, only that shape is moving now. You just if you put
Yes.
like this way, like this way, what is happening? The particle is actually vibrating, or it is just having a displacement along this perpendicular direction, or net displacement is zero. After some time again this displacement is zero. So but that shape is moving along with along the particular direction. If say one direction, one dimensional wave, it will be passed through in a single dimension, or it's a two dimension, like if it is on a plane or something, it will move like that way, or it's a three dimension, it can propagate through the space. So this is actually a representation of a wave. It is a movement of a disturbance or a shape or a phase from one side to another side of the medium without actual displacement of the particle or the entities which is causing. So the concept of wave is actually coming in olden times, when say, everything was based on this classical mechanics it was used to describe. So they only thought about a particle movement. They said that okay, this particle can move either in transverse direction or in a longitudinal direction. So different kind of wave, like a transverse wave, longitudinal wave, like that way that people introduced. After that, that is actually in the era of classical mechanics. Then it is came like that way. There is no need of a particular thing to move. Even the field can move. That kind of concept is came when that electromagnetics era came. So that time what happens, the electric field along the on the space itself can rearrange itself such that the energy can be transferred from one place to another place. That kind of thinking, that also wave. And the thing is that wave has a particular property which is actually described by wave equation. You may not that I'm not going to much about that one. The thing is that there will be an equation like the double gradient of the, you know, that wave equation, or I'm not going to that mathematics itself, but yeah, it's a function of a space as well as time. It's a equation which is connecting the spatial relationship of a entity. That can be either the particle, or it's a pressure, or it can be electric field, or it can be magnetic field, like that. So it's something like that. Don't think about too much about it. So this is actually the movement of a wave. Then we have much more idea how this wave can be useful, or how better we can describe, and that kind of thing. So then came the concept of a plane wave. What is a plane wave? What is a plane wave? A plane wave is a wave which is considered as when it is moving, the whole portion on the plane has a same phase or same amplitude. You can see that if a plane wave, you people knowing na wave, whatever wave
Yes, sir.
thinking, like when you are thinking about a wave, everybody will tell about a sine wave kind of thing. Okay, what is actually it is representing? You can easily represent it as like a wave in a mm, thread or something. But most of the simple wave can be represented in terms of a sinusoidal wave. Either it can be the displacement of a thread, or it can be the variation of the pressure, or it can be the variation of the what you call stress, or something kind of that. So what actually they are saying that it has an amplitude part and there is a propagation direction. And if you can actually, I told the wave equation is actually represented by a uh, equation which have both the spatial part as well as a temporal part, the time part. So they are saying that if a wave is moving like that way, this point and this point has exactly the same amplitude, and similar way this point and this point have the same amplitude, and the distance between these two portions is actually we called the wavelength if it is in the spatial domain. So what they are saying that if it is a plane wave, all portion in that particular plane will have the same amplitude. If this point is in that plane, then everything in this plane will be have the same value, and that plane is not fixed by this boundary. It is like an infinite plane, so it will be spanning from whole. So it is a simple entity which we can use, and we can say that okay, one plane is moving from one side to another side, like that way you can imagine, and that will be easier. But that will not be an ideal situation. So then there are another different kind of waves are emerged. This is the plane. So plane is moving, and there's like a, it can move like a, you can see that when a stone is dropped in a pond, it will give, the movement will be like a circular. Just think that that is happening in a space, that will make a spherical. So wave can move in the shape of a sphere, concentric sphere it can move. So that's concept of spherical wave also. Okay, that is some more, much more towards the real. Then only we are now thinking about Gaussian waves. What is the Gaussian waves? Why it's called Gaussian?
So maybe the phase distribution is in Gaussian form. That's
uh,
why.
what distribution?
Gaussian distribution.
Gaussian distribution
Yeah.
is where?
Um, I mean the phase. I think the distribution is in the.
Actually there is phase distribution is not Gaussian. Actually the
Okay.
cross sectional amplitude distribution is Gaussian.
Okay. Okay.
Okay, so
Yes.
you don't need to much think about the waves and other thing, just think a practical concept. I'm saying like that way. You know, you all people know laser beam. Laser, you know na?
Yes, sir.
Yeah,
And the course they said it is Gaussian in nature.
yeah. Just think
Yes.
that I have a laser diode or a laser equipment. Okay, so it will have an aperture from where the laser is coming. Okay, from here actually laser is coming. You know there is a laser beam is coming, and you spot it on a paper or something. How the laser spot look like on the paper? If your paper is something like this way, you will see some circular spot na?
Yes.
Like that way you will see. This is the thing which you are seeing in the case of a laser beam which is spotted on a paper. But if you look at this spot in a more thorough manner, you can came to know that it is not a, I draw like it's a, everywhere it is uniform. The spot is everywhere it is like uniform I draw. But look at a laser beam, you will see that it is not going to be a uniform spot. You can see that the central portion will be very intense. So you are looking at a laser beam. When it is coming, you look at towards it or just put it a paper and see. And the central portion will be very thick. Very thick means very intense. And the outside portion will be less intense, less intense, less intense. Like that way. It will be something like this way. Okay? Got it?
Yes.
Now you calculate the intensity across this spatial direction. Okay? What will come? I'm going to plot the intensity across the this graph. Now I am saying that this is my position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how will be my intensity at 0? This will be like very less. 1, then slight increase. 2, some more increase. 3, more. 4, very intense. 5, again decreased. 6, decreased. 7, decreased. 8, decreased. 9, decreased. 10, it's going like that way. And if you connect these points, you will get a shape like this way. Okay? The intensity variation across the spatial dimension is in this shape. And you can equate this shape with a particular function. And I am saying that this is y and this is x. I can give it as a function like f of x is equal to some k into exponential minus a x squared kind of thing. Got it? If you have a function like exponential minus x square kind of thing, the shape will be like this way. And this particular shape is called a Gaussian. Okay. Why it is called Gaussian? This actually give in the memory of a famous mathematician called Carl Friedrich Gauss. And this distribution is like a very common distribution. So, and this type of distribution is coming. So, your laser beam is in the form of a Gaussian distribution. What is the distribution? The distribution of the intensity or the amplitude of the beam on spatial direction or in the perpendicular direction, you can say. So that is why it is called a Gaussian distribution. Got it? So,
Yes, sir.
so it is not the phase in the form of Gaussian. It is actually the spatial or the perpendicular spatial distribution of the intensity or amplitude is in the form of a Gaussian. Okay?
Yes, sir. Yes.
Yeah. Now, now, yeah. Now actually you can go through the different concept of a Gaussian thing, and you can see that the Gaussian will have a self-focusing property also. So if it's a Gaussian beam, it will have a this kind of profile. Okay, and each plane actually represented by a Gaussian distribution. This is I am saying that this is my laser output or something, and the laser is coming like this way. And if you look at a different position, you can see the intensity will be something like this way. Intensity will be something like this way. That means the middle portion intensity will be high and the end portion intensity will be low. That only that meaning. Something like that. This will be like yeah. This is the thing of the Gaussian. And the we said that there is a plane wave. In the case of a plane wave, we can see that exactly all things are in phase. All the particles in the plane are in a phase. But in the case of a Gaussian, there is a phase delay comparing with the plane wave. So that is the question which they are asking. In the case of a Gaussian, there will be a phase delay. So if you're checking that Gaussian beam, you can see that okay, if the middle portion is something like this way, and after some time, if the plane wave is exactly like this way, Gaussian will have a phase delay of something like this. And as it is moving, it will be like something. It will not this much big, but yeah, there will be a phase delay. This is the property of a Gaussian beam. And how we can calculate that one? So, so we have the original expression of a Gaussian beam. Okay, what is the original expression of a Gaussian beam? Electric field will be proportional to the equal to amplitude omega naught by omega z exponential minus rho square by omega square z into exponential minus ikz minus ik into rho square divided by 2r z plus iz. Whether any in this portion any doubt is there? This you don't need to worry how it is coming and other things. You have to just remember that this is the Gaussian beam expression and this is an amplitude part and this is the phase part.
Sir, I
Yeah,
had a doubt like what that zeta function does. When ma'am explained, I didn't understand.
yeah, that is the now he said there is an ikz minus some rho square by 2rz.
Plus that extra term is there. So what
Yeah,
does that?
yeah, that I'm saying. You see this portion, this rho square portion is actually giving the phase distribution along the perpendicular direction. Rho is actually x square plus y square.
Okay, sir.
I will tell you. Now, I will see that this is a laser beam, laser diode. Okay, this is a laser diode, and a beam is coming from here. And how it will be like it will be like a Gaussian beam. It is coming like this way. Okay, and if you can see, you can see that it will be composed of different planes. You can say it will be like a different planes. One plane, another plane. It's not a separate plane. It's a continuous thing. I'm just saying that you can consider this thing as some different planes. Okay, but and each distribution is a Gaussian distribution. If you took a line here, you can see that this intensity will be higher and the side intensity will be lower. This middle portion intensity will be higher, side will be lower. Here also like that way, 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 here also like that way. So it has a, now you see that this is a full beam just coming out of the laser, but it is like a three-dimensional thing, like a pipe kind of thing. If you just equate with a pipe. So it has a z directional path as well as a xy directional path. This is the xy directional path. This is actually the z directional path. Along the pipe, it is the z, and perpendicular to the pipe, it is the xy. So the Gaussian has a phase change along z direction as well as this xy direction. Xy direction is actually giving across this beam. Z direction is actually giving along this beam. Now you see the original Gaussian function. This is the amplitude part. Don't consider about now. Now you see the only the phase part you see. Exponential I k z. Whether you have any doubt or something, I don't know whether you have came across, but you may have knowing that. I don't know whether we are remembering. But I k z, if the phase is coming like I k z, it is actually representing a plane wave. Got it? This is
Okay,
actually
sir. Yeah.
representing
Yes.
a plane wave.
Yes, sir.
Now,
Traveling towards one side.
yeah. Now you see, along with that one, there is a rho square by 2rz. Rho square is actually given by spatial direction across this one. So there will be some phase distribution along this direction. So actually that is given by that part. Now the third part is the zeta part. So this is an extra term which is coming in terms of a Gaussian. So actually you see that if you are thinking about a middle portion is of this beam, you just think that you are only considering about the middle portion of the beam. You are not at all considering about the other part, top and bottom part, only middle portion. In that case, say x and y will be, if you are taking a graph kind of thing, yeah, middle portion will be, so x and y will be 0. In that case, actually, this portion will not be there. Where you can say a rho square. Rho square is x square plus y square. If x and y are 0, then this portion is not at all there. But still, that time it is actually representing a plane wave shifted with a particular phase. And that particular phase is actually giving the difference from the Gaussian beam from the plane wave. If it is not a Gaussian beam and if it's a plane wave, only this phase part will be there. And this is actually giving the extra phase term which is arising because the beam is actually Gaussian. So this is actually giving the phase difference from the plane wave. You don't need to consider this one because you are only considering just consider the central portion of the thing. That time this thing will become 0. So this zeta part is actually giving the phase difference from the Gaussian beam. So you can see that what is the zeta is defined as zeta is actually tan inverse z by z naught. So This theta part is actually the phase difference which is giving from the plane wave to Gaussian beam. So that is actually your first question. So theta will be tan inverse z by z naught, and you are asking to calculate at z naught. So theta will be tan inverse z naught by z naught. So tan inverse 1. What is tan inverse 1? Tan inverse 1 will be 45 degree or pi by 4. Okay. In terms of radian, that will be pi by 4. Got? Any doubt?
No, sir.
Now, which of the following equation is corresponding to the Rayleigh range of a Gaussian beam? So, Gaussian beam have a different parameters. One of the parameters is it's a Rayleigh range. What is the Rayleigh range? Rayleigh range is there is a distance at which you can see the variation of your curvature or something like that. It's a maximum starting from the mean distance, how a Gaussian beam is changing from a plane wave. You can actually see that how a plane is changing from plane, spherical, and at a very far away distance you can see it is like again plane wave, and that variation is actually characterized by your Rayleigh range, and the Rayleigh range is defined as a Rayleigh range is defined as a z naught is equal to pi omega naught square divided by lambda. Okay, and now you see if this is a Gaussian beam and omega naught is actually it is the radius of this beam. So if you are seeing a beam like this thing, this is your omega naught, radius of the beam. So the area of the beam will be like how much? Pi into omega naught square. Okay, so just substitute the value, then you will get this Rayleigh range can be written as a pi omega naught square is equal to, you can write it as a by lambda, you can write, and depth of focus will be double of your that's a okay, that's the question now. So you can directly get okay, only direct question. Yeah, that question is direct question only. Pi omega naught square by lambda. So your answer will be A. These things actually you have to remember. Okay, this depth of focus and the Rayleigh range and this parameter, how the curvature is varying, how the beam waist is varying. These things actually you have to remember, and that equation also you have to remember.
Okay, sir.
Okay, now the depth of focus of a Gaussian beam is, that's the next question. So what is actually depth of focus? Depth of focus is the range at which the Gaussian beam is almost have the same size, and that is actually double of your Rayleigh range. Okay, so the depth of focus will be 2 into z naught. So we have 2 into, already we know z naught is equal to pi omega naught square by lambda. So it will be 2 into pi omega naught square by lambda. This pi omega naught square actually I can write it as a area. So 2 into a by lambda. So we can say that it is so 2 is a constant. So I can say that it's directly proportional to area and inversely proportional to the wavelength. So depth of focus will be directly proportional to the area and inversely proportional to the wavelength. Now we see the option. So the proportional area of the beam at its waist. So it's true. Inversely proportional to the area. That's a false. Directly proportional to the wavelength. That's a false. Inversely proportional to the wavelength. That's true. So A and D are true. But
Yes.
let's see. As Gaussian beam diverges from its waist, the radius of curvature of the Gaussian beam, what happens? I'm not opening this one. Just tell what is the equation of the radius of curvature of a Gaussian beam from starting from its focus point or the beam waist. What is the equation? R of z is equal to
Z into 1 plus Z naught by Z squared.
yeah z
The whole
into 1 plus z naught by z square. So now just see. If you want to see how it is happening, you can calculate a very analytical manner, but you don't have to calculate like that way. You can, if you want to get your answer easy, you can also calculate that manner also. Let's see. R of z is equal to z into 1 plus z naught by z the whole square. Or you can multiply that together, take the z into inside, and it will be like a z into z plus a z naught square by z. Okay. Now you see that what happens at this position at your beam waist. Z is equal to 0. What will happen? Here Z will be 0 plus Z naught square by 0. And this will be what? This will be a very big value. Correct? Na?
Yes, sir.
Yeah. So it is a very big value plus 0. What will be that value? That will be very big value only. So
Infinity.
it's, yeah. So it's like infinity plus 0. So at Z is equal to 0, R of Z is equal to infinity. So radius of curvature is infinity, means it is a plane. Correct? Radius of curvature is infinity, means it is a plane. What is
Yes.
happening after some time? Let it be at a particular distance, it is reached at z naught. If it is z naught, what will be the radius of curvature? This will become z naught plus z naught square by z naught. So what will be the value? This will, yeah, will become 2z. So here it is like infinity. At z naught it is like 2z. Now we see that it is went very far away. Okay, it is like a very big distance or infinite distance. So what will be the R of z value? So this z is become infinity plus z naught square by z. 1 by infinity will be 0. Okay, it is not exactly equal to 0. It is like it is a tends to 0. You can say that when the value of z is very high, this z naught square by z value will be very small, such that it will be like a 0. So it will make a 0 plus infinity. So if you add a very big number to a 0, you will get that big number itself. So it will be like a infinity. So at a very large distance also you will get a infinity. So the radius of curvature is a, at the 0 it is infinity, then it is coming to some value, then at far away again it is infinity. So it is like actually what happening is decreasing, then increasing. So you can say that radius of curvature starting from z is equal to 0 to infinity, what happens? Radius of curvature will decrease, then increase. Got it? What? Any doubt for this one?
The, both extremes it is okay, sir, but how it is somewhere decreases, how to find that?
Yeah. Now
How
you
it
can
indicates?
how it indicates means
Now at Z0 it is infinity, radius of curve, and
uh,
at infinity
it is infinity also.
the radius of curvature is
Infinity means it is
yeah, both
infinity.
it is at infinity.
Uh,
Therefore, it is
now you can see that at two extreme actually it is a infinity. Now just see it is your trick. Just put a value like a here, which is the value which is easier to put z naught.
yeah,
Put a
and here it is infinity. But you are saying there is a dip.
yeah, because I calculated a z naught. So z naught is coming between 0 and infinity. That is true.
Oh,
Z
okay,
if there is a z naught value, that will
hmm.
come always in between 0 and infinity now.
Okay, okay.
Yeah. So
It
if
is
you
in
put
between. It is
yeah, so you put in z naught in the so you will get the value 2z. 2z
okay. 2z.
2z
That is
2z naught. Yeah,
some
that's
value. It is there.
yeah. So that value will be definitely it will be less than
It is less
infinity.
than yes, infinity. Correct.
Yeah.
Okay. Thank you.
Okay. Okay. So it will like what will happen? Actually, what is happening at the central portion of your beam, or that the beam waist, the Gaussian beam will act like a plane, and very far away also the Gaussian beam will act like a plane wave. In between, actually near the value, you can see that 2z naught. 2z naught is like a it's like a very big curvature. It's like it has a very big curvature. Radius of curvature is here. So it will have a plane nature here. Then it will have a radius of curvature, very high radius of curvature, and it is like a decreasing. Then again after some time, what happens? This curvature will again decrease. Sorry, increase, and it will increase, and when it is far away, it is again look like a plane. So it is like starting from 0, it is plane. Then it is like from high, it will come and go down, and at 2z naught, it will come at a minimum position. Then again, it will start radius of curvature start increasing, and it will become again like a plane.
Okay,
So
fine.
so from there, actually, you can see that it increases, decreases, then increases. Now, yeah, from 5 onwards, our mathematics actually starts. The radius of the Gaussian beam within which 99% of its total power is contained. You know how to do calculate this one? Actually, it is done in class also, I think. The radius of the Gaussian beam within which 99% of its total power is contained. Okay?
Yes, sir. That was learned in class.
Yeah. You want clarification for this one? How the power is calculated, how the 2 pi r is coming, and
Yeah, madam informed. Madam made a calculations and show
yes,
only say 88%, another is 99.
yes. So that is sufficient. Whether I have to explain again, or you want, I can explain, no problem.
Yeah.
Okay, sir.
Now you see, which is actually the expression. This is everything is starting from here only. This is our original expression of a Gaussian beam. Correct? E of rho z is equal to a naught into omega by omega z into exponential minus rho square divided by rho square into exponential. Here in the phase part, actually what is the, this is an imaginary term. Do people know? This is actually imaginary term.
That
Okay.
is the pace. But
Yeah. But the phase containing this I. What is this I?
That's the image.
This is a complex term actually. This wave function is actually a complex function just containing a both real as well as an imaginary part. And if you want the amplitude, you are seeing a beam or laser beam now. Can you actually measure or see or understand how the electric field is actually behaving? Can we see the electric field or can we detect an electric field? Actually, no. We cannot detect an electric field. Why? The electric field will be always associated with a complex term. You know the complex numbers?
Yes.
Yes, yes.
A complex number can be represented like a plus ib. Do people know?
Yes, A plus A, Z, A plus J,
Ah,
B.
yeah, I or j. Yeah. Ah. A complex number can be represented by z is equal to a plus ib or jb, where I is equal to square root of minus 1. And this term is actually a imaginary term, and this term is actually called a
Yeah.
real term. And what is the magnitude of this one? To call,
Magnitude.
that will be the modulus of this value, and that will be equal to a square plus b
B
square.
squared.
How it is coming? Actually, we are multiplying this z into z star. So it will like a plus ib into
Minus A, A
a
minus
minus ib. So if you multiply this one,
A squared minus B squared.
a square minus b square, and this minus b
And
square
I
will
squared also.
containing the I square will also,
Minus
yeah.
A squared minus J.
Uh, so
I
it will
plus.
become a square minus 1 b square. So it will make a square plus b square. Okay. This is a one representation of a complex term. Similar way, there is another representation of a complex term also. Now the same complex number I can represent in terms of a exponential term. Z I can represent it as a sum r into e raised to I theta. Okay. Some radial representation of this one. This can be, and this e raised to I theta is called cos theta plus I sin theta. Okay. E raised to I theta is equal to cos theta plus I sin theta. Now we just see. I am saying that I can represent a complex in terms of r e raised to I theta, and e raised to I theta is equal to cos theta plus I sin theta. So I can write r into cos theta plus I sin theta. So it will be like r cos theta plus I into r sin theta. Now it is looking like a plus ib, correct na?
Right.
And you just multiply. What will be the modulus of the value? Z is equal to z into z star is equal to r cos theta plus I r sin theta into r cos theta minus I r sin theta. What will be like that way? R cos theta the whole square plus sorry minus
Okay.
IR sin theta whole
Square
square. So it will be R
square
square cos square theta plus R square sin square theta. So what will be that value?
R
R
squared.
square is common. Cos square theta plus sin square theta will be 1.
What?
So it's like a R square. Mod cell will be like a square root of z star. So if you take a square root, it will be like R. So the same thing you can represent it here. Z can be represented as the modulus value of the complex number into a phase value. Here actually now you see that we did a very big step to get the modulus value of R. We convert it to cos theta and multiply cos square theta plus sin square theta. Now you see here actually it's very easy. Z star will be equal to R. Only you have to change the sign
Minus.
of this I. It will be like a minus I theta Z star. And if you multiply Z to Z star,
R squared. It is 0.
yeah, Z square will be equal to R square into e raised to I theta minus
Minus
I theta. So this term will be 0. E raised to 0 will be something raised to
1.
0 will be 1. So it will be like R square. So, so this representation has a very good what you call it compatibility such that we can make it a very calculation very easy. Now you can see this is the actually a representation you are seeing in terms of a Gaussian beam here. Now you see, so you are getting a electromagnetic beam, the amplitude of an electric field. This is containing a real term here. Okay, because here there is no I term is here, so it will be like as it is. But here you can see that exponential minus ik z minus ik p rho square by 2r z plus I into eta into z. Because of this I is coming here, what happened, you want to take a intensity as the square of your electric field or amplitude. So what will happen, when you are taking a modulus square, in that this is E. Actually what is your intensity? Intensity will be E into E star. So this term will be as it is. Now you see, this term will be as it is. What will happen is E star. I took E star of rho z. It will be A0 omega naught by omega z exponential. This term will be again, it will be the minus rho square by omega square of z into exponential. What will happen? The sign will change. It will be
So
like a
it is a exponential zero.
ikz plus ik cos square by 2r into z minus I into theta of z. Now you what you have to do? You have to multiply this together. What will happen? A into a naught into a naught. It will become a naught square. Omega naught z into omega naught by omega naught z. It will become omega naught by omega z the whole square. Exponential something into exponential something. The exponential value will multiplied by 2. So exponential into minus 2 rho square by omega of z square. What happened this multiplication? This is minus ik z plus ik z. It will get cancelled. This is minus ik rho square by 2r z. This is plus ik rho square by 2r z. That get cancelled. This is plus iz eta z. This is minus I eta z. This will cancel. And this exponential term will containing a exponential of 0. So that will be 1. So if you multiplied it, if you are taking an intensity, what you are getting? You are getting the square of this amplitude part only. This is actually the real issue which we are facing everywhere. You can say that we are saying that all light is traveling in terms of electromagnetic waves or electromagnetic field. Actually, this electromagnetic field is a complex term that containing a intensity or amplitude part which is a real, and there is a phase part which is an imaginary part. But what happens, our eye or our camera detector or anything, they cannot differentiate this phase part. They everything is actually working based on the intensity only. So whenever you are taking an image, the phase is lost. Whenever you are seeing an image, the phase representation is lost. So actually we cannot measure the exact phase, but we have some depth information also will come from the face, that you will see. Yeah, that will come in your holography, other things that will also come in our course, that right? But yeah, don't worry. But what happens here, you can see that now this, when you are taking an intensity, your whole amplitude portion is actually come to a particular form, and your all phase information is gone, and the intensity information containing only your amplitude information, and the all phase information is actually lost. So you don't worry about your phase when you are dealing with the intensity or power or energy, or when you are dealing with these things, actually you don't need to worry about the phase, because this is actually the absolute value of your electric field strength, or the square of the electric field strength, which is an intensity, or the power or the energy, that does not have an information of a phase. So phase value actually you will lost. So so you will reach at that point. Now you can see that. Yeah, this is that question. Yeah, if you took this like that way, if you are taking intensity, you will have a square term, and there's omega naught by omega z square term, and a exponential minus 2 rho square by omega into omega z square term. Okay. Now, now you can see that this is what you are seeing. Whatever you are seeing is a particular Gaussian thing. Okay. Now you want, now you have an intensity equation. Now see, intensity equation containing some intensity function, as well as it's containing a rho. Rho means a x square plus y square. Rho square is actually x square plus y square. That means it is containing the information of it is actually saying how your intensity is distributed among this plane. If there's a Gaussian distribution is there, it's like this way, how the intensity is distributed among the plane is represented by this rho square. Okay. Now, now, now this, but you can see that this is actually a area. Not sorry. This is actually a intensity. Intensity means it is giving. Now, what you want to see? You want to see actually it is giving a how spatially the intensity is distributed. The function is actually giving how spatially the function is distributed. Okay, this portion will be having high value, and yeah, because you can see that this is actually you can see the rho square by omega naught square z. So if you have a value of this thing, actually it is containing a lot of, this direction is a z direction, and this will be like a x and y direction. So based on the x, y and z direction, it will have a particular value. If you want the value at this position, take the z value.
0.
Yeah. If it is actually at a beam waist, then z value will be 0. Sometimes this plane may not be exactly at the beam waist. Just think that you are taking a plane at this position, then here the z value will be 0. Now just think that I am taking a plane at this position. This is the plane you are taking. Here the z value will not be 0. It will have a particular z value.
Yep.
Maybe like 2 or 3 or something value will be there here. So it depends on the which plane you are taking, the z value vary. And at what point you are taking depends on that one, your x and y value will vary. So it will be a function of x, y and z, and it is actually give a particular value at a particular point. Got it? Understood? Now 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 you only know what is the value at a particular point. That only you are going to know. But now you want to know what is the full value. What you have to do, you have to calculate this position, this position, this position, like that. You have to calculate the whole position. Actually this is not at all going to end. It's like intensity is decreasing only. It's like it will be like infinity, it will be going. So you have to go and see how much it will go. So you, what if you want the total power, what you want to do, you want to calculate all the intensity at each position and you have to add. But that is not going to be a simple task, and that we already know that the intensity also varying from this position to this position. So what we will do, we will do an integration. Okay, how we will do an integration? Now we say that this is a position, and I will say that this is, and I know that this whole, this is a symmetric thing. So around a circle, the value will be constant. So I will take a value of intensity, and I know that the intensity will be constant throughout the circle. It's the center of the circle. Throughout the circle, intensity will be constant. So I have a intensity I, and I know that throughout the circle it is constant. So I will multiply with a 2 pi r. Okay. So I get a intensity on a circle. Now I say that I will take a small increment of r, that is a dr. dr. So intensity into 2 pi r dr will be a small increment of this dr, and like that way I have to take from 0 to particular r or 0 to infinity. That is my concern. So it will be like a integration from 0 to some particular r. So that will be my power. So that's why this 2 pi r dr is coming. We are taking an intensity and we are considering it as symmetrical, and around the symmetrical thing it will be 2 pi r, and we are taking an increment of small dr, and we are going to integrate it from 0 to particular r. What is that will be the radius of my concern. Got it? Any doubt for this one? This is the way we are calculating the area. It's actually normal mathematics only. This is the way which will calculate all other things. It's not at all intensity. It's like that. It's a calculation of a distribution. If the distribution is symmetrical, this is the way we are calculating along a plane. So it's the calculation along the plane. That's why this our limit is from radius 0 to some particular r. So So we already know the value of I. So it will be like I naught. Actually, I am representing an I naught as my this value. If anybody want to do this integration, anybody want me to do this integration as with the full thing? This is not a complicated integration. By seeing all together at a time, you may be thinking that it's a complicated, but actually not. Whether you people thinking it is a complicated thing, whether you feeling it is a complicated, tell. You can tell, no problem. If it is feeling complicated, tell. I will solve here itself. We can solve. Anybody typing or not? I am not seeing anything. Or you can tell also. The telling will be much easier. You want to do the integration? But
It's fine, I guess.
the integration is fine.
Yes, sir.
Somebody want, I can do. No problem. That I am saying. So you can give the limits also. So it is like
Rho square by 2.
yeah. This is like instead of I, it will be like a square into omega by omega naught square.
That is a constant.
Yeah, that's a constant, and there will be like a minus 2 rho square by omega square,
That
and
will be the same.
this is the thing which we are putting 2 pi rho d rho. Here actually I am going to put a trick. Here I know that's a 2 pi rho d rho, and this portion is actually if exactly same as the derivative of this one, I can directly do the integration. That's a trick of integration. So what I did, I calculated what will be the derivative of this portion. Minus 2 rho square by omega square. What will be minus 2 rho square by omega square will be?
It's the same, and
It will be like a
that
4
will
rho into 4 rho divided by omega square. So here I have 2 pi into rho d rho. So I want to make it as a 4 rho by omega square. So I just multiply the 4 rho by omega square here, and similar way I will multiply the other side also. And this 2 pi I took outside, and there will be a constant here. Actually, this whatever value you are seeing here and whatever value you are seeing here is also same, exactly same. But here I made a trick in such a way that whatever the value inside this exponential, this is actually the derivative of that one. So I have a form like integral e raised to k dk kind of thing I got here. Okay.
that's correct, right?
So after that, you gave limit, you apply the limit here, and you will get a exponential form like this way. What is the limit you people are putting? You are putting some arbitrary r or arbitrary rho value. So you will get a form like I naught into pi omega square by 2 into 1 minus exponential of minus 2 rho square by omega square. And if you're taking that raw value as infinity, means you are going to cover all the area. So that will be your maximum power. So take as it is, and in that case you will get a P max will be something. and this portion will be equal to, you can say that is a maximum power, I naught into pi omega square by 2. And if it is exactly at your beam based, this omega will be equal to omega naught. So you can directly put I naught into pi omega naught square by 2. So that will be your maximum power at the z0 plane of your Gaussian beam. And there will be a function like 1 minus exponential minus 2 cos square by omega square. Okay. Actually, this is a your important equation. Now with this equation, actually we are going to put it. Now we are saying that okay. Now I can say that p by p naught will be is equal to 1 minus exponential minus 2 cos square by omega square. Now my question is that at what time or at what radius my power will be 99%. So I want to see that at total power will be 100%. I want to know that till 99% how much will be the radius. So p by p naught will be 99 by 100, or it will be equal to 0.99 is equal to 1 minus exponential minus 2 cos square by omega square. And minus exponential you put other side, take this 0.99 this side, and it will become 0.01 is equal to exponential of minus 2 rho square by omega square. One side you got a number and another side you got a exponential. What you will do? Take a logarithm of both sides. So take a natural logarithm of both sides. This exponential will become minus 2 rho square by omega naught square, and here there will be value of minus 4.605. The log natural logarithm of 0.01 minus 4.605, and do the calculation. You want the rho square, and you already know the beam waist number. You don't need to you don't need the beam waist number. It should be multiplication of a beam waist number. So you will get a rho as a 1.517 of rho naught. So what is the meaning? If you have a Gaussian beam, something like this way, some circular kind of thing, and even though it is looking like a spreading towards infinity, within 1.5 value of your z naught, within this portion itself, your 99% of power is actually confined there only. So you don't need to worry about the value which is beyond that limit. So if you have a lens, or you just think that okay, your your laser is actually going to hit it on a lens, and if the lens has a radius of 1.5 omega naught, it will take your 99% of your energy of your Gaussian beam. So you don't worry about much width, and you already see that there is like a safety factor, or they will usually take a double of that one. So if you just take some 2 omega naught of your things, most of the energy will be considering inside only. Even though we think that this Gaussian is like a spreading towards this that sides, but that's a very less amount. Most of the energy is actually confined inside your, that is near the central portion.
Radius.
Yeah. Okay. So you will get the value as 1.5. So the value you have to put. Now, for a Gaussian beam to travel long distance propagation, beam width should be small, large, not affected by beam width. Answer. What is the answer? How you can propagate long distance? Now you think that I know that I have a laser beam.
Diverges.
Yeah. And I have a laser beam. And I want to just think that I want to reach it some very far away distance. If the laser is like diverging like this way, whether it will reach here with full power, or if it is like a very sharp, which is better, this one or this one.
Second one.
Second one is always better. So now, what is the difference between this beam and this beam? This beam have a higher divergence, and this beam have a lower divergence. So I want a beam having a lower divergence. Now we can directly go. You can check what is the parameter which decides the divergence. What's the parameter decides the divergence? Beam divergence theta is defined as a omega naught by z naught. By seeing itself, we will think that or if we increase the omega naught, divergence will be increased. Correct, na? By seeing here, we may think that if omega naught or the beam size is increased, divergence may increase. But no. Why? Because there is a z naught here. Z naught is not a constant. It's a constant for that particular beam, but it is not independent of omega naught. It's actually z naught is equal to pi omega naught square by lambda. So z naught have a omega naught square term. So it will be like theta naught is equal to omega naught by z naught, or omega naught lambda divided by pi omega naught square. So it will be like lambda by pi omega naught. So lambda is a constant, pi is a constant. Now omega naught is coming at denominator. So it is like theta is equal to inversely proportional to omega naught. By seeing this one, don't think that theta is directly proportional to omega naught, because this z naught containing a omega naught square. So net effect will be like theta is proportional to inversely proportional to omega naught. Okay. So now see, you want to decrease the divergence. So this angle should be less. So omega naught should be high. So beam width should be high. Okay. So the answer is large. If you have a large beam, so your beam divergence will be less. So a beam of helium neon laser 632.8 nanometer has traveling along a z-axis and have a waist of 0.1 millimeter. Find the distance z at its radius of curvature r is 2 meter. Okay. How will do? We have direct equation. Radius of curvature. We have what is the radius of curvature? Radius of curvature r is equal to z into 1 plus z naught by z the whole square. So you can directly put that equation there. Okay. Now you see the question. So lambda is equal to given by 632.8. Omega naught is given as a 0.1 millimeter or 0.1 into 10 raised to minus 3 meter. Z we don't know. Radius of curvature is equal to 2 meter. So we have the equation like r of z is equal to z into 1 plus z naught by z the whole square, or expand it, you will get it 2 into 2 is equal to z plus z naught by z. Okay. And you can calculate your z naught value, and z naught value is come as a 0.05 meter. substitute the whole value there. Z is, you have the, this is actually a quadratic equation, correct? If you solve this one, you will get a if you expand this one, you will get a quadratic equation. That is z0 square minus 2z plus z0 square is equal to z square minus 2z plus z0 square is equal to 0. This is a quadratic equation, and quadratic equation will have two roots. And how you will find out the roots? Z, or the root will be minus b plus or minus square root of b square minus 4ac divided by 2a. What are the values? B is equal to minus 2, a is equal to 1, c is equal to z0 square. Okay, put the value here, plus 2 plus or minus square root of 4 minus 4 z0 square divided by 2. This is your mathematics to be solved. And z0 we already find it as a, it's like it will come around 0.05 meter. Okay, 0.05 meter square, what will be like 0.0025. Okay, any doubt?
It is negligible. Compared to 4, it is negligible.
Yeah, so 4 into 0.0025 will be, we cannot say negligible because it will give 2 value. So what the value you are going to get? I am saying that I will get a value. If it, this is actually, here I did some trick kind of thing such that I can get the answer. Here I didn't completely calculated my full answer. Why? Because I have the option there. That's why I didn't completely calculate the answer. Or anyway, we can actually completely calculate the answer here. And now we can say that, so otherwise you people may have some confusion. So this is the equation. So what will be the values inside? Is equal to z is equal to, so 2 plus or minus square root of
4
4 minus 4 z0 square. Z0 is equal to 0.05. 0.05 square will be 0.0025 into 4, 0.01, 4 minus 0.01,
3.99.
3.99. So it is like 3.99 divided by 2. So 1.997. So it will be like 2 plus 1.997 by 2 and 2 minus 1.997 by 2. Now you see that 2 plus 1.997, it's around, it's like 2 only. 2 plus 2, 4 by 2, it will be around equal to 2. And 2 minus 1.997, what is this value?
0. Almost 0.
Yeah, it's almost 0. 1.997. But why I am calculating? By 2.
0.00.
Yeah. So it's like a 1.5 into 10 raised to minus 3. So now it is like there are two answers. One is 2. Another answer is 1.5 into 10 raised to minus 3. Now actually, which is correct or which is wrong? Is there any wrong answer or is there any correct answer, or only one you can take or something option, or you can take both?
We should take.
Actually, you can take both. Here you can see they are asking radius of curvature. They given as a radius of curvature is 2 at a particular distance. Now you are getting two values. Why you are getting two values? you can see our question which we did some time back, that here when z is equal to 0, the radius of curvature is infinity, and at z is equal to at a particular point, radius curvature is decreasing, and at infinity, radius of curvature is infinity. Now we can see that it is actually coming down and coming up. So you can see that this is actually what a radius of curvature. So if you put a radius of curvature along y-axis, you can see that there will be always two value, which one is actually near your z is equal to 0 point. One point will be there where there will be a radius of curvature. The same radius of curvature you will get at a far distance also. So this point as well as this point have the same radius of curvature. Okay, and that value actually you got from there. So one value you can see the 1.5 into 10 raised to minus 3, which is very near to your z is equal to 0. Another is actually very far away. Okay, then why that two answer is correct only? Nothing. Option they given only two. In that one there is no multiple option, so you have to choose two only. Okay, you have to see the option whether any other things are there. So since this is a correct answer, you have to take that choice. If there is another option containing 1.5 into 10 raised to minus 3, you are supposed to choose both. In this option, 2 is the only most appropriate answer. That's why it is 2. Got it? And it is not like that it is only 2. Okay?
Okay.
Yeah. So it is like that based on the options given, z is equal to 2. But actually z have a one more value there. And that is not in the option, so you cannot choose that one. Actually, that z has a 2 value. Next, an argon and laser having lambda is 5 launched to the moon. The laser waves radius is 50 mm. The distance to the moon is 384400 kilometer. Assuming the output from the laser is Gaussian, the beam radius of the beam on the moon is this is your direct calculation. You know, na? Omega is equal to omega naught into square root of 1 plus z by z naught whole square. Okay, and that z by z naught we can write it as so lambda is given, omega naught is equal to 50 millimeter, z is equal to 384400 kilometer. Actually we don't know the omega, so omega is equal to omega naught into 1 plus z by z naught the whole square raised to half. Z naught we know that z naught we have to calculate pi into omega naught square by lambda, so it will come as the value. I didn't directly calculate it, I directly put the substitution there. If you took that one and you have to calculate, what you will get 1258.4 meter. So 1.258 kilometer. Okay. So it will be around 1.25 kilometer. It will come. Any doubt for this one? Whether I have to do? But this is a direct question. Now, the ninth question. For a Gaussian beam, lambda is equal to 550 nanometer, and the half divergence angle is equal to 0.8 millirad. I have to make sure that 0.8 milliradian. Okay, 10 raised to minus 3 is there. Then the Rayleigh range is. It's also a direct question. This is a theta naught. Theta naught is equal to omega naught by z naught. And we have z naught, we have pi omega naught square by lambda. Substitute that one there, and what we will get? You have to do one thing such that you have to convert the omega square, you convert it to z value. So you calculate omega naught square is equal to lambda z naught by pi, and square this one, you will get a theta naught square will be equal to omega naught square by z naught square. What you want? Actually, you want z value, and omega naught square we are having lambda z naught by pi. Put the value there. Lambda z naught by pi into 1 by z naught square. It will become 1 by lambda by pi into z naught. So z naught will be equal to lambda by pi into theta naught square. Theta naught we already know. This is a 0.8 milliradian. So substitute the value, and you will get a 0.273 meter. Okay. Any doubt in that question? Now the 10th question. A 1 milliwatt helium neon laser is produces a beam spot size of 2 omega naught, 0.1 millimeter. The optical intensity at z is equal to z naught. We have to calculate it. And at the center of the beam. Okay. Check the answer. We can go. Yeah. Now we can see the intensity. Yeah. There is a chance that you will misrepresent that intensity as a whole things, but actually make sure that intensity function is actually giving a point function. It is actually giving the intensity at each point, not as a full. So you cannot multiply intensity to the area and get the power. Okay, because the intensity is not a constant throughout the plane. If it is intensity is a constant throughout the plane only, you can multiply. Otherwise you have to do an integration. Okay. Now you see, this is the question. So we already have the intensity is equal to, this is the intensity equation of intensity. Intensity is equal to a naught square by omega z whole square exponential minus 2 rho by sorry 2 rho square 2 rho square by omega z whole square. Okay, and they given z should be z naught, and in that case when omega z will become omega naught into root 2. That you know na,
Yes.
omega is equal to omega naught into 1 plus z naught by z whole square raised to half. So when is equal to z naught, it will become 2, it will be half, so it will be root 2 omega naught. Substitute that value here. So you will get at the point where at the center of the position. That means rho is equal to 0. Put the rho is equal to 0. This whole exponential term will become 1. And z is equal to z naught, omega naught becomes omega naught into root 2. Put that value here. So you will came to know that intensity at 0 means at the center at z naught will be is equal to I naught by 2, means intensity maximum intensity by 2 at the center position 0, means at the center of the spot at the Rayleigh range will be equal to I naught by 2. Now our aim is to calculate what is our I naught. That I said that we cannot directly multiply the power and area because the intensity is not a constant. Now you see. Now we already has the power at omega naught plane. This is the thing which we calculated in our integration. It will come out like that way. I naught by 2 into pi omega naught square will be our total power of the laser beam. And that power will be like a constant. Now you can say that this is the power. So what I want, now I want I naught set will be I naught by 2 I want. Now you go here, see here already I naught by 2 is here. So it will be like a power divided by pi omega naught square. Power actually already given 1 milliwatt. And omega naught is also no 0.05 into 10 raised to minus 3. Because they are given the beam width as a 0.1. So omega naught will be beam radius, that will be half of that one. That is 0.05 millimeter. So it should be like a 10 raised to minus 3 we had to multiply. And take the square, do the calculation. What you will get? You will get the answer as 1.27 into 10 raised to 5. Okay. And out for this one?
That is right.
Correct only, na? So these are the assignment questions solved. Now new assignments are coming, how the Gaussian beams are transforming and other things. And how, so it is like a much more involved, you can say. Because you have to put more effort. Just by logical, you cannot get all the answer. But yeah, optics is something much more simpler in such a way that we can just think and calculations are much less and equations are very, very less. You can just get an idea, just think about how it is happening and you will get almost all the answer. But here, yeah, here actually you have to think a little bit more. That is actually, yeah, that difficulty is there. So what are the other doubts you can ask such that you can see what are the difficulties or some other things you people are facing? You people are facing any small problem also you can tell. I don't have any issue for trying to solve or doing that. Yeah, anybody giving comments? I'm not listening.
Sir, I had a doubt in the week 8 lectures. Like,
We take like,
it was related to the Q parameter.
okay, that's like when it is going through the lens, na?
Yes, sir. Like, how
Okay,
did that Q parameter come? Like, I felt it was sudden.
okay, I'll check and tell because I didn't. I get.
Okay, okay, fine.
Okay, you do one thing, na? We just put it as a. You just ask it in the group such that so that I can answer it. You don't.
Okay, fine. I'll send a mail, sir.
Yeah.
Hello, sir.
Yeah. Done.
Sir, can you please again explain the question number 4?
Oh.
Yes, sir.
Okay, you see, a Gaussian beam diverges from the waist. The radius of curvature of the Gaussian beam, what it is doing? What is the nature of the or the behavior of the Gaussian beam radius of curvature? So this is actually a Gaussian beam, and this will be the beam waist. What is actually mean by radius of curvature? Just think that you have a light bulb or something, and it is emitting some light. So how it will be look like? The light waves is coming, will be look like a sphere, concentric sphere. Okay, it will be like a concentric sphere, and the sphere will have a curvature, and corresponding radius is called radius of curvature. Now we think that okay, when it is like very far away, what happens? It's very far away, like yeah, it will be like a big, 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 and very far away it will look like a plane. So if it is a planar nature, we can say the radius of curvature is infinite. Okay, when it is a more circular nature, it will have a finite radius of curvature. When it is a planar nature, it will have a radius of curvature infinite. This is the funda. Now you see, Gaussian beam will also have a radius of curvature. At each plane, it will have a different radius of curvature for that particular plane. Now, you cannot say that's a particular plane, yeah, at particular distance. Now we have an equation to calculate that one. So for the Gaussian beam, the radius of curvature is defined as R of Z is equal to Z into 1 plus Z naught by Z the whole square. So what it is giving? It is giving a function saying that this is Z is equal to Z naught or Z is equal to 0. When it is moving from this position to this position, how the radius of curvature is changing. It's moving from this position, how the radius of curvature is changing. How it is changing. How it is changing, it is giving. Now see, now we want to calculate how it is changing. Our initial position is always we start from at the center of the or the beam waist. So that position is called Z is equal to 0. So I want to see the what is the radius of curvature at Z is equal to 0. So this equation I can expand and write it as Z plus Z naught square divided by Z. Correct? Any doubt for this representation? Now I can say that at Z is equal to 0. What is happening? This Z is equal to 0 plus Z naught square by Z. This is like Z naught square divided by 0. No, actually you should not write it like this way. It is like that way we can say that okay, it is tens. Actually we have to represent in terms of a limit. But yeah, for just representation analysis, I am just putting like this way. Now you see that what is this value? The second term, something divided by 0 or something divided by very small value. What will be this one? This will be like infinity. Okay, plus there is a 0 term. So if you add infinity items to a 0, you add something to 0 will be that something will be. So if you add infinity to the 0, your answer will be infinity. So what will be like that way? So at Z is equal to 0, it will be like a plane. Radius of curvature is a infinity. That means it is a plane. So you got that at Z is equal to 0, it is looking at planar. Now I am saying that at a very far distance, at very far distance, I am saying it as an infinite distance. So at a very far distance, what will be the value? Now also we put at very far distance, I can say that z is equal to infinity. So infinity plus z naught square by infinity. Still I am saying that actually you should not put it as like equation. This is like a limiting value, but yeah, for just representational purpose I am saying like this. Okay. Now we see something divided by infinity. What is that one? This will be changed to 0. So it will be like infinity plus 0. That will also become infinity. So at a very far distance also r is equal to infinity. At 0 is equal to r is equal to infinity. Now here easier position is to put a finite number. Just to think that at z naught, what will be the value? So I can put it here. Z becomes z naught plus 1 plus z naught by z naught the whole square. Z into 1 plus z naught by z naught will be 1. 1 square. So 1 plus 1 square will be 2. It will make it 2z. So in between it will have a particular curvature and z is equal to 0, it will look like a plane, and z is equal to infinity also it look like a plane. So we can directly say that anyway this r at 0 it is like infinity, at infinity also it is infinity. So nothing can be bigger than infinity. So that 2 z naught will be always smaller than infinity. So your radius of curvature will decrease to z naught and again it will increase to infinity. So we can say that radius of curvature will decrease and then increase. Why we can say like that way? We know that two side is infinity and middle portion there is a finite value. So there's a definitely it will decrease and increase. Okay. Okay.
Yes, sir. Thank you, sir.
Any other doubt?
Sir, I had one doubt in Oslo, sir.
Yeah. Done.
I didn't understand the difference between the base coordinate system and the global coordinate system.
Yeah, that actually now we can say that local coordinate system is actually what they are doing in that exercise. Actually, you may have repeated and did the same thing. Na? Actually,
Yes, sir, but
yeah.
they were saying like one is local coordinate system and then what is the base coordinate system? Is it as same as the global coordinate system or is it different?
That one actually I think they are doing one coordinate they are fixing and based on that one I think they are calculating. And the return thing actually I didn't go through that much more. Okay, if
Oh, okay,
I can do one thing that also you put it in that one so that I can
okay,
go
okay,
through and
okay. I'll do it. Yes.
in global coordinate system actually they are fixing one coordinate as the global coordinate and all
Yes,
other
sir.
thing you have to define your coordinates thing. So it's like a directly you are defining every coordinate such that it will take the value. The local thing
Okay,
actually based on one coordinate you are defining the other one. That's the way it is
okay.
normally it is going.
Yes, sir. Okay.
Any doubt?
Okay, clear.
Fine, sir.
Okay, can we
Yes,
stop?
sir. Assignment
Thank
part
you,
of
sir.
it is clear.
Yeah, that you try with the other assignment also. Yeah. Directly assignment we cannot solve as it is, but yeah, you can, if any some doubt is there also, you can put it there such that we can give. If you have some doubt regarding like the how it is solved, sometimes yeah, you people may be thinking that okay, you people already know this one. Yeah, if you don't worry about anything whatever we are knowing or not, if you are not understanding, just put it as a comment or something like that, you can, no problem.
Sure, sir.
Okay.
Thank you.
Okay.
Thank you, sir.
Okay, thank
Oh, thank you, sir.
you. Okay. So I'm closing the meeting. Hopefully nobody has
Yes,
any doubt. If any doubt is
Okay,
there,
sir.
you can put it in your this
yes. Thank you, sir.
group. Thank you.
Thank you, sir.
Okay, thank you. Bye.
Okay.
Okay, bye.